So as we talked in the last video, the main idea in support vector machines is that we need to separate separate the data with the maximum margin. So this is the main idea here. Let me once again tell you how we are going to do that. So let's suppose we have this graph and we have some classes here. So this is some classes. Okay, this is one class, and let's take that this is another class. So what we want is that we want a line that separates them with the maximum margin. We do not want a line like this, or we do not want a line like this or line like this, but what we want is a line that separates with the maximum margin. And like we humans can by just seeing the graph, we can see a line would be like this. Okay, so this was the main idea. Now let's talk about some things first. So our line equation, what as we said in the last video, that this is going to be +1 and then this is going to be -1. So what we are going to do is, as we know that our hyperplane is going to be this, so wx plus b, or you can say w transpose, where w is nothing but your theta, or you can say this is your weight and this is your bias, and this is our line equation. So you must know this formula. I have talked about it in almost all of my other machine learning algorithms. So as we said here, that if anything is is on the right of this line, then it is going to be belongs to class 1. That means y is 1. And if anything is going to belong to this side, then y is going to be -1. Okay, so we can say that this is going to be you can say that this is going to be nothing but equal to 0. Okay, so this is our line equation. This is our optimal hyperplane, and what we are going to say, that we are going to say w transpose x plus b if it is greater than 0 plus b plus b. If it is greater than 0, then we have a positive class. That means our output is 1. And if wt x plus b is less than 0, then it is going to be -1. Now what you can do is, or let's not just jump to this, but I can say that if we have this, it means that our x belongs to a positive class. Okay, it means that our x belongs to this class, and if our is less than 0, then it means that our x belongs to a negative class. Okay, now what we are going to do is, we are going to pass this value into a function. Let's say that function is g. So what we are going to do is wt x plus b. This function is going to give us the main output that we want, that is 5. Okay, so what it is going to do is, let's say g of z is going to be +1 if z is greater than equal to 0. So if z is 0, basically it means that if this is greater than 0, then our output is going to be 1. And if this is -1, then if our output is going to be -1 if z is less than 0. So this is what we want to do. Okay, now how we are going to do that? Let me just rub this and then explain to you. So let's suppose you have this graph again. So what I'm gonna do is, let's say we have this class, we have this class, we have this class, and we have this, we have this. So what I'm gonna do, what I'm gonna say is that let's suppose I have a line like this, I have a line like this. So what it is going to do, what we are gonna do is we are gonna find the distance between this point and this line. Okay, so we are going to find this distance, we are going to find this distance, we are going to find this distance, this distance, and this distance. And what our main aim is, our main aim is to maximize the minimum distance. So let's suppose this is distance 1, this is distance 10, this is distance 3, 4, and 5. So what our main aim is, our aim is to maximize the minimum distance. So what is our minimum distance? Here we have the minimum distance as 1. So what we are going to do is we are going to move this line in such a way that we want to maximize this distance. So we do not have here 1 anymore. What we are going to do is we are going to shift it in such a way that this distance is not going to be 1, but it is going to be maximized, whatever it can be. It may be only according on the basis of the data, it may be 1, it may be remains 1, but it is not it might be possible that it is going to shift on some angle so that it can maximize the distance. Now what are our conditions here? And one more thing is that how we are going to find the distance between this line and this point. So for that, what we have is we have a function, or we have a formula that is going to be weight transpose x plus p divided by L2 norm of w, that is weight. And what is L2 norm of w? Basically what is L2 norm of this is going to be this w0 square plus w1 square plus w2 square. So this is going to be the L2 norm. And if you are not understanding all of these terms, I have already explained what is W, what is W0, W1, W2, what is bias in my previous playlist, like linear regression, logistic regression. I have explained everything, so that's why I'm not explaining this again in this algorithm. Okay. So now let's look at the formula that we are gonna get, or let's look at what we are going to find. So our main aim is to maximize the distance. Let's say that distance is gamma, and we want to maximize this distance such that, so it has a constraint with it, such that yi into wt xi, or let's just not take this, you will only get confused. So what we have to do is y times wt x plus p is greater than equal to gamma. So let me tell you first of all what we are doing here in this part. So let's suppose if this is positive, if this is a positive number, and this is also, then this is also going to be positive, as we talked earlier. Okay, so ultimately it is going, what it is going to do, let's suppose we have this data, we have this line, we have this point, this point, this point. So what we are doing here, what we are saying here, we are saying that if this part is greater than 0, then it is going to be positive, and if it is going to be positive, then it means that our y is also going to be positive. So it is just going to give the distance of like this. We are taking the absolute value here. Okay, and if we have, if it is less than 0, then it is going to be a negative value, and it is also going to be -1. So again, what it is going to do, it is going to just find the absolute distance. We are not taking the what do we say, the sign here. We are not taking whether the number is positive or negative. We are just finding the distance between them. Okay, that's why we are multiplying it. And now for because we have to do this with every point. Okay, so that's why I am going to use I, xi. So what it says that every point when we want to maximize this alpha such that every point should be equal to or greater than this alpha. But now this is our main institution that we want to maximize the distance, as I said earlier that the idea is to separate the data with the maximum margin. But now this is very difficult problem to solve, and the reason is that we want to maximize this part. Okay, and this part is being used in this constraint. So it is very hard to solve such kind of problem in which you are in which you are changing a value, and then that value is also being used in a constraint. Okay, so that's why it is very hard to solve this equation. So for that we have to reformulate this equation.